Okay, welcome to the Markforged webinar on introducing the industrial series of products. Thank you everyone for joining. I'm John Riley. I'm the VP of Product here at Markforged, and I'm joined by Daniel Leong, who's one of our content engineers. And let's get started. Okay, brief look at the agenda for today. We'll start with introducing Markforged to those of you who don't know who we are. We'll talk a little bit about the value of composite 3D printing, and we'll do that in the context of some customer stories. We'll close by reviewing the new industrial series lineup, and then we'll end with questions. I don't know that I'll get to everyone's questions during the question period, but if we miss your question, I will be sure to follow up with you afterwards via email. All right, so let's give a brief overview about Markforged. We were founded out of MIT in 2013. We shipped our first printer in 2014, and our goal as a company is to unlock the next 10x innovation in design and manufacturing. We have a global fleet of installed printers. Our printers all run cloud-connected software, so we're able to you're able to print them from anywhere in the world, and so we have a very large installed base that we've sort of rapidly put together because we're somewhat unique in terms of 3D printing. We're the only company that offers the full range of materials, and that goes from plastics to metals to composites, and that's resulted in like a new way to print parts, a new series of parts that can actually be printed. And it turns out that strength actually matters a lot to your part. So when you're using a printed component, often the inability for it to survive or be strong enough is an inhibitor to use. And so we'd like to tell you a little bit about application spaces and why Markforged unlocks new printable parts. So just in general, there's three categories that you'll hear talked about with 3D printing. The first is sort of the traditional early category of prototyping. These prototypes are primarily cosmetic. They're great for fine detailed design reviews or for fit checks or for color. And then there's end use parts that gets talked about a lot, but it hasn't really seen a lot of use yet. You have automotive, aerospace, and medical, all the very familiar verticals there. But interestingly, also manufacturing tooling, things like jigs, jaws, grippers, and fixtures. This is an application space where 3D printing has a lot of competitive advantages. If you have the ability to print strong parts, though, you start to really expand the places where they can be used. So in the prototyping space now, beyond just a fit check part or a part that maybe shows you the color of what you're expecting to get in the final product, you can actually print something that's strong enough to function as a prototype. So you can start to make functional prototype parts. In the case of end use, now you can print parts that are actually able to stand up to harsher environments or stronger applications. And then I've left colored in here the manufacturing tooling segment, which we'll talk a bit more about, where you can print a whole bunch of parts that were previously machined out of aluminum, jigs, jaws, grippers, fixtures. The thing is, nobody ever walked into a Home Depot and asked for the weakest hammer they had. When you're talking about tooling, strength is like one of the most important pieces. And now with Markforged, you can actually get strong parts. So that's it. The high-level summary is you can build stronger, 23 times stronger than traditional 3D printing plastics like ABS. You can ship your parts faster, 50 times faster than the lead times on a machining process. And you can save about 20 times the amount that you would spend on a part compared to machining it out of aluminum. So this is going to enable us to address a much larger variety of parts from the 3D printing perspective. So let's drill down into each one of those one at a time and look at some customer stories. We'll start with strength. Traditional 3D printed parts are weak and they tend to break. I talk to customers all of the time who have tried 3D printing parts for various applications, and it's almost an expectation that those parts will fail at some point. They don't have great tolerances. They have very poor surface finishes, low heat deflection temperatures, and typically, if you're printing in a material like ABS, it's not going to do a good job surviving some of the harsher environments you see, like machine tool cutting fluids, for example. But with Markforged, our parts don't break. That's because we reinforce them with continuous strands of carbon fiber or fiberglass or Kevlar. And so let's go through some customer examples. There's a major aftermarket automotive manufacturer. They make these exhaust systems, which have these like really long, unique geometries to fit underneath all the various cars. And they make these welded assembly fixtures to help like fit check and build them together. This causes a lot of inefficiency in their process. They've got like a bunch of like fixtures that are just stored in racks. But they tried printing parts out of ABS to replace these fixtures, but they kept breaking when they were using them. They printed a part on Markforged printer out of carbon fiber, and the fixture did not break. So now they're able to replace a large amount of their tooling and get tooling on demand faster. So there's a lot of benefits there to a strong part that can be sort of printed on demand. But also they need to be accurate, right? In addition to like holding the really accurate shape for those weld fixtures, here's an example of like incredible accuracy where a US-based electronics manufacturer, it seems kind of weird to say that, but there are plenty of electronics that need to still be manufactured in the US, like defense electronics and medical grade stuff. They had a circuit board pick and place tray, a tray that you pick components off of, in this case, an optical sensor. The trays that they were using they were injection molded and they didn't have a tight enough tolerance around the parts themselves. So the machine would often miss the part when it tried to pick and place it off the tray. We were able to print a pick and place tray out of onyx, which is our nylon with chopped carbon fiber, and hit a tolerance tight enough that their fixture changed to 100% yield. So the pick and place machine was able to accurately locate those parts. And they were held to very tight tolerances. And that's important when you're making parts that are going to be used in end-use applications like tooling. And then there's a lot of cases where only Markforged parts are going to survive, where your traditional ABS will fail. Dixon Valve and Coupling is one of our case studies. You can read a lot more about them on our website. But they were machining out of aluminum these robotic gripper jaws that went on the end of a robot arm. And they decided to start an initiative to see if it would be possible to replace them with a printed part. And so they printed parts from a whole bunch of different companies. They used a service bureau to do it. And all of them failed except for the reinforced Markforged part. They then subjected many of those parts to a cutting oil bath. And due to the nature of our parts, which are made out of nylon, only our parts survived exposure. So now you've got a really useful combination of parts that are both strong and corrosion resistant, able to stand up to sort of the harshest environments. So only Markforged can print a part that's reinforced with a continuous strand of fiber, carbon fiber, fiberglass, or Kevlar, which is not on this graph, and yield end results that are stronger than aircraft grade aluminum. So let's talk about speed now. Getting your parts faster is very important to many applications. Traditionally, if you're machining aluminum, you've got a lot of wait time in there. Tooling lead time is long if you send it to an external machine shop, and sometimes with an internal machine shop. If the part is non-critical, which is many times the case with a fixture, it can take up to 6 weeks to get that part back. And then you just have to add those on in serial nature if you need to iterate your design. So you can quickly rack up months of design time trying to iterate on a machined part. This becomes particularly acute if you've got a manufacturing line where you have a broken tool that's taken the line down and is taking you a long time to repair. This is sort of where you can lose a lot of money in your process. So some customer examples on this, same-day critical fixtures can be printed on Markforged machines. Lipton Tea from Unilever has a manufacturing line where they now print their fixtures from Markforged, and that cut their lead time on some really critical components of that manufacturing line down to getting them back the same day. So they're able to make sure that line is up and running and working well. And then if they need to make a change, they can really quickly iterate on it to get the right fit for the part or to put a different product down the manufacturing line. So they're able to be a lot more agile in their manufacturing process. And then, the same way that it gives you agility, that's a basic trait of 3D printing. The strength means that it can actually be used in the harsh production line environment. We keep that line running, and that's very important. A major automotive manufacturer had a fixture where the chassis would crash down onto these 4 locator pins. The pins were made out of machined aluminum, and they were breaking frequently from the stresses. They were able to print. The engineer on the line got one of our printers, printed a part reinforced with fiberglass to replace that pin, took it home, beat it with a hammer. The part didn't break, much to his surprise. He replaced 1 pin in 1 cell on the line. It didn't break while the rest of them continued to break. He then replaced every pin on that line and then on every line, and the parts continued to survive. And they're able to be printed, obviously, much quicker than remachining aluminum. And so they were able to keep that line running, and then realized that there's a lot of sideways applications besides just these pins where you get a lot of benefits from being able to 3D print your parts. One of those benefits is cost. Nothing has a return on investment typically in the 1 to 3 month time frame. But if you're able to replace machined aluminum with Markforged printers, this is how fast we tend to return. It's kind of almost unmatched, and it seems a little bit crazy, but tool cost is actually very expensive. If you have to CNC machine a part, that can cost anywhere from hundreds to thousands of dollars. If you need to iterate again, now you're rapidly multiplying the cost on top of that. And then complexity in a machining process for aluminum or another metal starts to become prohibitively expensive. But with Markforged, our printers tend to pay for themselves very quickly. Here's an example of a keychain company that had a machined aluminum sonic welding fixture, which you can see here on the left. They printed it, saved $720 per part, and they paid for that machine in 1 month. And then they took it and iterated on their development cycle, and they actually were able to be more productive in new product design. They went from 16-month product cycle down to a 2-month product cycle. So they got multiple benefits from using a strong parts printer. And Dixon Valve, who we talked about earlier, those gripper jaws that they printed that stood up to the 110-pound force on the robot arm, they saved $281 a piece on each one of those. That machine paid for itself in just a few months, and then they bought a couple more machines. And of course, the machines keep paying dividends after that. Dixon tells us that on projects where they 3D printed tooling, they save on average $33,000 per project. So they've seen an incredible return on investment. And keep in mind that these parts, while being strong, are often actually lighter because carbon fiber gives you properties that are lighter than aluminum, so they can even run their manufacturing line faster, increasing their throughput. Okay, and one more example of printers paying for themselves is Aero Global. They designed a soft jaw for work holding, and they saved $398 a piece. That machine paid for itself in only 15 parts. So we're seeing many of our customers who are able to print parts that they couldn't previously 3D print because of the strength and material properties from Markforged, and they're able to get really quick return on investment in doing so. And then stronger, cheaper, and faster is great, but there's one more benefit that we were going to cover, and that's productivity. The amount of time you spend doing work that doesn't directly relate to the part outcomes that you're after. Anyone who's worked in developing tooling for manufacturing, they know that it's slow. It takes a lot of busy work. Many times, if you're machining, you have to create and dimension tedious 2D drawings to get those parts made. Then you have to, this is the worst part, get them quoted and then issue a purchase order through the accounting department. None of this is very fun. Those need to be filled out and approved. And then, of course, you have to deal with the logistics of shipping and receiving. Or you can have those parts on site. You know, one way that we improve productivity is by flattening the supply chain. So a hygiene company who sort of a global manufacturer uses the X7 in their headquarters to design, slice, and develop their production tooling, but then plans to put one of these in each one of their locations around the world, so they can simply send the print file and the printer on site in the manufacturing facility in, say, Brazil, can that same day print the tool that they need to either fix the line or get a new product running off of that line. So it makes it a lot faster. You don't have to worry about lead times on shipping. And then we even improved productivity on non-3D printed parts. You guys, if you're familiar, may recognize the sort of famous 3D printed jet nozzle from GE. But actually, you might not know that the fixture that holds that thing in place when it's CMM'd and then laser marked is printed on a Markforged machine. So you can very easily like create best-in-class fixtures that'll hold your parts in place while they're operated on the line. Our parts are not only stronger, but they have really high resolution. And because of the characterization of the nylon, we won't scratch your metal parts. So it's actually a very friendly tooling surface. If you had aluminum that was scratching parts, you don't have to worry about that when you're using onyx. Okay, so what does that all add up to? Strong parts that save you time and money. They reduce cost, you get product to market faster, and you can keep your production lines running. That's some incredible and compelling value, and only Markforged can deliver it. So let's talk about the industrial series, the lineup in which we have just announced. The first printer is the X3. Industrial grade performance really starts with our all aluminum unibody enclosure. We build that around an ultra flat gantry system. We add a machined aluminum stage and a kinematic bed coupling so you can relocate the print bed to like a 10 micron accuracy. And then, we precisely grind that print bed platform to make sure it's ultra flat. Then we close the loop with software. We instrument each machine with a full sensor suite, including motor encoders and a calibration laser that's accurate to 1 micron in Z. That's so accurate that we use it to actually compensate out single-digit changes in room temperature as the machine sort of grows or shrinks due to its coefficient of thermal expansion. We can make sure that the distance between the print bed and the nozzle is exactly accurate. The X3 prints engineering class parts. These are 20% stronger and 40% stiffer than ABS. The material is called onyx. It's nylon with chopped microcarbon added to it. Its resolution is down to a 50 micron layer height, accurate to plus minus 125 microns, and has a large build volume, 330 by 270 by 200 millimeters. And that laser that I talked about, I'll show you on the next page, but the X3 starts at $36,990 suggested retail price. This is sort of a graphic demonstrating, it's obviously blown up a little bit here because these are like micron level variations in bed flatness. But before each print, we use this laser micrometer to scan the print bed to create a map of the geometry of that print bed, the stack up, in fact, of the print bed to the print head, to the machine itself and the gantry. And then we compensate that out of the system while printing. We then print like a line on the print bed and scan it to ensure that you get the perfect layer height on your first layer, so it's exactly right and sticks great to the bed. And this is all in pursuit of making these printers like really accurate, reliable, and repeatable. Industrial grade means that it's just going to work for you. You're going to get the results you need. The next step up the product line is the X5. Here's where you start continuous reinforcement, in this case fiberglass. That'll give you a part strength that's 19 times ABS, 11 times flexural stiffness. Again, you'll have a 50 micron minimum resolution in the layer height, 125 micron accuracy, and the same build volume that you just saw on that X3, the large 330 by 270 by 200. Again, you'll have the in-process inspection, and the MSRP is $50,000, $49,990. And just to like give you a visualization of what a part looks like when it's been reinforced with a continuous fiber, here we're looking at an onyx shell. That's the black material, which is the encasing material. And then you can see that these strands of fiberglass are woven continuously throughout the part, one layer at a time. And that's how you get that incredible strength and stiffness, and how you're able to start to actually replace machined metal in many applications. Okay, and then finally the X7. With the X7, you're now able to print continuous carbon fiber and Kevlar as well. That gives you the strongest, lightest parts, 23 times ABS, 25 times flexural stiffness, same resolution, accuracy, and build volume for the entire industrial line. The X7 adds actually calibration to the laser in addition to that in-process inspection. We'll talk about that in a second. But now for load-bearing applications that need like real strength, the strongest parts, you can make parts that are stronger than aircraft-grade aluminum, and they're actually 40% lighter, and that's the value you get from carbon fiber. The MSRP on this machine is $69,000, and if you know Markforged, you may have known it as the Mark X. We've now renamed that to the X7. It is the top-of-the-line industrial printer. And here's a visualization of another part, in this case reinforced with continuous carbon fiber. This is a brake lever. If you've had a chance to see any of our sample parts, we often show a brake lever from a Ducati, so you can feel the difference it makes to take a part that's been not reinforced at all and compare it to a part that's reinforced with a continuous strand of carbon fiber. Often at trade shows, if you find us at our booth, we'll ask you to try and break it. These parts are incredibly strong and can stand up to sort of the harshest applications. And then accuracy is like really important as well. You want to make sure that the part you intend to print is the part that you get. So the X7 also has laser inspection. You can set a scan on any layer of your part, and the X7 will pause when it gets to that layer. It'll scan the surface of the part, and you can go in and dimension it and check and see if you've gotten the exact tolerances you were looking for in some critical parts. And if not, you can stop your print earlier and fix it. Over time, we're going to automate this so that you can specify critical dimensions and it will be inspected automatically. And if it's good, you'll just get a nice email at the end of the part printing. And if not, we'll let you know that something is wrong and that the machine needs recalibrated. So now you have a full lineup of industrial printers from Markforged that can make strong parts. This unlocks the ability to 3D print a whole new range of components that you couldn't print before. And we don't like to leave anyone behind, so if you start in any one of these products, you can upgrade to the rest of the lineup. So at any time you decide you need more strength, there's a path, and we wanted to make it affordable so you don't break the bank in doing so. So even if you started with an X3, you can step all the way up to the X7, and it won't cost you that much more than if you'd started with the X7 itself. This gives you a chance to find the exact best fit for your application and get the machine that's right for you. And so you go from Onyx to Onyx reinforced with fiberglass in the X5 to Onyx reinforced with carbon fiber, Kevlar, fiberglass, and high-strength, high-temperature fiberglass in the X7. All right. That's the lineup and the end of the content for today. We're going to open it up to questions. Daniel and I will try to field these from the viewer. Bear with us a second while we get this to a size. All right, if you have questions, feel free to put them in. Okay, first question: does the Onyx break like ABS or bend like a nylon? It's so Onyx is nylon reinforced with chopped microcarbon. It behaves more like nylon than ABS, but the addition of the chopped microcarbon fiber makes the part about twice as stiff and twice as strong as a basic nylon. And so that means it has really nice tolerances when you print it, but it still has flexibility, and it will still bend before it breaks. And if you see one of those sample brake lever parts that we make, you'll be able, if it's not reinforced, you'll be able to bend it. So yeah, the answer is bends, not breaks. Okay, let's keep going. So is the X5 the lowest cost machine that will let me print continuous fiber? In the industrial series, the answer is yes. But if you're looking for a desktop printer, and we have a lineup of desktop printers that are also fiber capable, and you might check out the Onyx Pro if cost is an issue. Those machines are built on the DNA of the industrial series, but they don't have all of the features, and their build volume is significantly smaller. Okay, what is the difference between the X3 and the Onyx One? Okay, so the difference is similar to what I just described in that the X3 is an industrial grade printer with an incredibly large build volume, 50 micron layer height, in-process inspection, flatter gantry system for better accuracy. It's designed sort of to survive and deliver great parts all of the time. The Onyx One is a desktop grade printer. It prints Onyx as well, so you get a similar material selection there, but you're not going to get the 50 micron resolution, the inspection, and the smaller build size. Okay, let's see. The X5 slide mentioned in-process inspection. Yeah, that's incorrect. We'll fix that. I'm sorry, that was a typo. In-process inspection starts only on the X7. Okay, what is the surface finish in stainless steel metal printed part? Yeah, if we of course print all of the materials. If you'd like to check out the metals, I encourage you to go look at some of the parts that we have on markforged.com. Or if you'd like, you can request a demo with one of our value-added resellers. They'd be happy to bring out one of their sample metal parts and show it to you. But generally speaking, we get really nice surface finishes across our entire range of parts by taking the time and effort to develop all of the materials in-house. That means we do materials in-house, software in-house, and the hardware is designed right here in our building and then manufactured in Massachusetts. That results in like incredible accuracy and really nice surface finishes. They're almost unparalleled in the space of FDM style printing. Okay, elaborate on the continuous fiber in 3D printed parts. Is the fiber limited to the plane of the print bed? Yes, so when we talk about the strength of the continuous fibers, the fibers are routed through your part one layer at a time, progressively in Z. You have a great degree of control over the layout of those fibers in the software package, which we call IDER. You can go in there and you can change the orientation of the fill of the fiber, or you can have it concentrically lap your part from the outside in or the inside out. That means you can create almost like a plywood panel of continuous fibers on the way up your part. But the limitation is that you just have the strength of plastic in the Z-axis. And that means that, like any manufacturing process, usually 2.5 axes of strength greater than aluminum is fully sufficient, but if you need 3-axis strength, you can look at some of the really interesting studies that the application engineering team has done around how to achieve that. You can put a couple of bolts and screw through your part to compress the Z-axis and achieve strength there as well. Okay, let's see. Can we get these slides? Yes, we'll record this presentation and share it with the audience. What's used for support? So we print same material supports. They attach very loosely to the part, and you tear them off almost like an accordion very easily by hand. So we use the exact same material for the supports. Okay. Let's keep going. Is Onyx ESD safe? I noticed a pick-and-place machine used in an electronic setting. Good question. We have some data on surface resistivity of Onyx. It's very high. It may be a little too high to dissipate ESD, but we've had people use it in those applications and not have any problems. But I believe the resistivity is just above what's typically defined as an ESD material. Okay, let's keep going. How do the various raw materials compare in cost? The easiest way to answer that question is to go to the website, or I would actually encourage you to try out the software. You can request a software trial from markforged.com. Anyone can then go in and create an IGER account. You can upload your part to the account, and it'll slice it for you, and you can select the materials that you'd plan on using. And it'll tell you both how much of the material you're using in that individual part, how much it weighs, and what the part cost is from a material perspective. So we create some really nice tools to help you understand exactly how your part's going to turn out. And so I would encourage you to maybe try out that IGER software. It also gives you an opportunity to learn about how to reinforce parts, to play around with the different levels of reinforcement that you could do and the different fiber layouts. Okay, let's keep going down. How do you ensure that the fiberglass is fully wetted into the plastic? Well, so we actually pre-preg our continuous fibers to ensure that they're fully stuck throughout the entire part, and we put a lot of effort in development and making that happen really well. How does continuous fiber compare to aluminum in fatigue? Daniel, do you want to field that one? We've seen a lot of applications where aluminum breaks after several fatigue cycles. Continuous carbon fiber at its end point will also tend to break. If you're worried about like continuously taking impact, then we'd point you towards a different continuous fiber than carbon fiber. Kevlar might be good for that application. Anything to add, Daniel?
Yeah, so it depends what kind of fatigue you're looking at. If you're looking at something that you're expecting to exert some amount of force on without any expected deformation, then it should be fine. Carbon fiber's one weakness is that it's very stiff and it's very brittle, so if you're looking to bend it a lot, odds are pretty good you'll break it, but the force it takes to bend it is significant. The nice thing about Kevlar is that while it will deform, it has a really large region of elastic deformation, so it's much more likely to return to its existing shape. So if you're looking for something to flex repeatedly and come back to the same strength as before, then Kevlar is your way to go. If you're looking for something as strong as possible that likely won't flex, but if it will flex, it's probably going to break, carbon fiber is going to be that way. But to be clear, carbon fiber is an order of magnitude stronger than Kevlar in terms of flexural strength, so it's a whole different ballpark.
Okay, let's keep answering questions here. Sorry, there's a lot of questions, so we may not get to all of these, but I'm going to give it a good try. Somebody asks about aerospace certification. Today, our Onyx material has the flammability rating of nylon, effectively, which is around V2. In most conversations we have with aerospace customers, to fly parts, they need it to be around V0 or V0 specifically. So we don't yet meet flight grade parts, but that doesn't completely block their application in the aerospace industry because there's a lot of manufacturing that goes on where there's opportunity to use these parts on ground operations. And so we've seen a lot of traction there. What is the Z direction strength? So in Onyx, Z direction is the strength of plastic. And specifically, it's about 80% of the published strength data for Onyx. But again, you can very easily design around any Z strength requirement you need. There's a lot of different application examples of how to do those designs to take Z strength into account. So we find that it's very rarely a limitation, even without taking special design consideration. Just orient your part in the correct direction. Okay, let's keep going. Can watertight parts be made? There's various post-processing you can do to parts to make them watertight by coating them in various sealants. We have a lot of customers using these parts in water-based applications, and so it's a pretty common use for them. The Onyx is hydroscopic. That's another question. It will absorb some moisture over time. But that doesn't really impact part performance because if you need the strength, you're actually reinforcing it with the substructure of that continuous fiber, which does not change or flex. Okay. Printer layer height is advertised as 50 microns. This is without carbon fiber. What's the layering with Onyx with carbon fiber? So that's correct. A nuance of the resolution on the printer is that when you are printing with fibers, the minimum layer height is equivalent to the height of that fiber. In the case of carbon fiber, that's 125 micron layer height.
In the case of all the other plastics, it's 100. So the default is the default we print with is 100 micron. 50 is specialized. We generally use 50 for super specialized parts, and specifically parts that have low angle contours. Onyx prints so well by itself at 100 microns and at steeper resolution. So for example, if you're printing a block or something that really only has steeper contours, you really won't notice the difference between 100 and 50 microns. 50 only is really necessary when you're printing something that has unique features that tend to be flatter and have more distance in between the ends of each layer. So it tends to be that 100 microns is usually good enough, but 50 is just kind of that extra level of resolution if you need it.
Okay, there's a couple of questions around printing speed. As some of you may know, we recently introduced a feature called Turbo Supports. That prints those same material supports that I was telling you about at about twice the speed. We do that by printing some bigger supports and then a small layer of interface supports, which then touch your part. The removal remains the same. You just strip them out, so that substantially reduced print times. And we're also in the process of testing for rollout a feature called turbo mode, which will, at its asymptote, about double the print speed on any individual printer. But if you want speed, the answer to speed in 3D printing is parallelization. That is to say, if you have 10 printers printing the same part, you're now making parts 10 times as fast. And so if you find yourself up against a limitation, many times we see customers add additional machines and have them operating in parallel. All right, let's look for another couple questions here. Can I get a copy of the presentation? Yes, we'll share copies of the presentation. Is the X7 the top of the line system we offer? Yes, the X7 is the top of the line system in the composite side of the business. We also offer a metal printer that's called the Metal X, and it's maybe a little bit more premium than the X7. You can find that on Markforged.com, and we'll be doing a webinar on that one later on. There was another question about post-processing that had scrolled past. All of the parts that you'll see on our printers are not post-processed anyway beyond like removing support material by hand or with a pair of needle nose pliers. And you don't need to do any sort of baking or polishing on them. They work straight off the printer with those strength metrics that we shared. Okay.
So there's a question about joining parts and printing parts larger than the build plate. I actually gave a webinar a month and a half ago about exactly this subject. And just to that point, we have a ton of resources on our site in terms of how-tos, in terms of how to leverage Markforged machines to print better parts. And so if you go to either our blog, which is markforged.com/blog, which has a bunch of how-tos, or our resources page, which is markforged.com/resources, you can see all of our old webinars, you can see our case studies, and you can see any of their videos that we've created. And there's a lot of resources there that should help you kind of figure out how to use the machine. One of the things that we try to work on as a company is making sure that when someone purchases a machine, that's not the end of the relationship. So we want to make sure that customers are using the machine to the best of their abilities. So that means creating a lot of guides, and thankfully they do exist. So in answer to that question, check out markforged.com/resources. There's a webinar on that subject.
Okay. There's some people looking for different specification sheets, one for Onyx. These should be available. I think you have to go through a contact wall.
Yeah.
But you should be able to find those material properties on the website. If not, we'll follow up an email and get those to you, as well as like comparisons between the machines. Someone asks what type of maintenance is required for each of the X machines. These are industrial grade. They're very reliable. So, but there are wear components like with any machine. In this case, sometimes you'll need to swap out the Bowden tubes and the nozzles, and occasionally you may need to sort of, retighten the belts and make sure that everything is sort of exactly accurate. If maintenance is a concern, we do offer success plans, which cover both wear and tear components as well as accidental damage, sort of like AppleCare almost. And so you can ask a reseller about what we have there. There's a lot of ways that we try and make sure that you have the parts that you want, and you keep getting the parts you want reliably. Okay.
We have time for a couple more questions. So someone asked a little bit more details about fiber orientation. As John said a little bit earlier, fiber is limited to an XY layer. However, in that XY layer, we provide a bunch of strategies for laying out fiber in different orientations. The best thing that we can advise you to do is just try out Eiger. You can go to our website and try it for free. And in that, you can upload any STL you want and try laying out fiber in different orientations. If you want any further information, you can check out our blog and resources page. What we can say is there's a couple different high-level regimes in terms of what particular orientations you want to lay out fiber, and then there's a bunch of smaller knobs you can turn. So basically how much fiber you want in each layer, what layers you want to put fiber in. You can kind of get as granular or as broad as you want when it comes to fiber, and there's a ton of resources on our website about that.
Okay, there's a lot of questions about metal coming in. The specific topic here is the industrial composite series. The X3, the X5, and the X7 print composite parts, which are plastic reinforced with continuous fibers. If you want to learn about metal, I'd encourage you to check out our website, and I think there's going to be a future webinar coming up on the 12th of September that will cover the metal printing process, so I encourage you to attend that. But I'm not going to field those questions today. Let's see. I'm kind of going down the list, trying to not answer ones that have already been asked.
So I guess there's a lot of questions about difference between the desktop series and the industrial series. And so John's talked a lot about the kind of just like the general industrial quality. One really good example of that is the laser. So while the in-process inspection is only usable on the X7, the X3 and the X5 also have the laser. What they use the laser for is two things. One, they do laser-assisted bed leveling, which is really good because instead of using 3 points to level, you use a 20-point scan. And you can use the laser to have instant feedback instead of using the shims, which kind of takes any chance for user error out. The second thing it does is what we call adaptive bed leveling. So it's kind of mentioned briefly in the presentation, but what it does is it scans the bed and compensates slightly for any slight issues in the bed because no bed is perfectly flat, although they're very, very close. And so what that ends up doing is making sure that your first layer is perfect every time. If you wanted, you could print a one-layer placemat with these parts, and it'd be perfect. And so that really helps for a number of reasons. The main one is that a lot of print failures happen early on because the bed is not perfectly level or because the bed has problems, and that totally mitigates that problem, which boosts one of the few small reliability issues the Mark II has, which is to say a very small issue, but it goes from like 95% accurate to like 98%.
And we have motor encoders for out of plastic detection, better location of the print head so we know exactly where it's at in software. And of course, that's all before we get to the big difference, which is the build volume. Okay, let's keep going. There's a few questions about if Onyx is food safe or FDA compliant. The answer is no. There's a couple other questions about tapped threads. And the answer there is that one interesting feature of the Markforged machines is that because we print at room temperature in the print enclosure, you can actually pause the print mid-print. If you've designed a cavity into your part, you can drop a nut, a threaded insert, and then you can resume printing over top of that. So you can actually have metal threads for attachment of these tools to your manufacturing line. And then the last question I'll take, but we'll still follow up via email to many of these, is are these machines available immediately? And yes, they're all shipping now. So you can go ahead and order whichever one you think best meets your needs, and that should be, and get the lead time from your value-added reseller. All right, thank you everyone very much for attending. Again, I'd like to direct you to markforged.com where you can find a whole lot of information and assets, and encourage everyone to try out the Eiger software there. You can basically learn everything about your part, reinforcing it and how we work, up to actually hitting print. Thank you.
Thanks, everyone.